have recorded perfect. We've also recorded previous lectures, and those can be found on the KITE website. So today I am delighted to introduce Dr. Tilak Dutta. Tilak is a scientist at the KITE Research Institute. He leads the engineering health team, which aims to provide individuals with disabilities and their caregivers with the tools they need to live safely, independently, and with dignity. His team's focus areas include preventing falls, caregiver back injuries, and pressure injuries, and improving the accessibility of our surroundings. The title of his talk today is Increasing Safety, Independence, and Dignity with People with Disabilities and Their Caregivers. I look forward to the presentation, and Tilak has confirmed that he will pause for questions throughout his talk. So at that time, please feel free to raise your hand or type your question in the chat. There will also be time after the presentation for additional questions, so if you prefer, you can save your questions for the end of the talk. So without further ado, I would like to welcome Tilak, and I look forward to his presentation today.
Great. Thank you very much, Alina. Thanks to everyone who's joining us today. I really appreciate you taking the time for this. I'll try to make it worth your while. I've tried to pack in a lot of information here, but I do want to answer any questions that we get along the way, as Alina mentioned. So please do feel free to type stuff in the chat. I'll try to keep an eye out for that. Or Alina, you can draw my attention to that if I miss anything in the chat as people are talking here. Okay, so I'll go through. Yeah, so I've been working at Toronto Rehab Institute for about 20 years now, and I think one of the key lessons that I've learned is the biggest risk to our health is inactivity and isolation. And so really what our team does is try to support is try to complement, I would say, all of the great clinical work that happens at Toronto Rehab that focuses on, I would say, the individual trying to, for example, if someone might be at risk of falls, the clinical side of our hospital focuses on trying to help improve their strength, their balance, encourages them to be more active. Our team tries to think about what are all of the other things we should be thinking about that can help encourage people to be active and prevent them from being isolated. And that includes thinking about their environment, thinking about what tools can we give people that will help them be in that environment in a safer way so that they can do the things they need to do and the things they want to do with safety, independence, and dignity. So I'm going to take you through an overview of a few of the projects that we work on. And I'm not going to go into terrible depth, but the idea is if you have questions, please bring them up. We're talking about things like giving people better winter footwear to prevent slips on ice, prevent tripping on sidewalks, making intersections safer, improving accessibility of outdoor spaces, indoor spaces, and supporting caregivers by preventing back pain. So we'll start with our work on preventing slips on ice. We know that every winter, after every snowfall, really, we see these spikes you see here. These are spikes of visits to the emergency room. And pretty much after every major snowfall, a few days later, we go through this cycle where the snow that fell melts during the day when it gets a bit warmer and the sun hits it, and then it freezes, and then it becomes we get an icy situation, and then people start slipping and needing to go to the hospital because they've hurt themselves. Our team, for a number of years now, we've been looking at what tools can we give people to prevent slips on ice? Specifically, we've been focusing on developing better or testing footwear to identify the best winter footwear we can give people. We do that testing in Winter Lab. This is a picture from the side with a picture of the inside superimposed on it. And I'll show you what that testing actually looks like. This is Jeff Fernie walking back and forth here, by the way. He's the former institute director here who kind of conceived of all of this testing idea. So inside this lab, we have this 5 meter by 5 meter ice floor. That's the pink ice that you see there. And you can have people on this safety harness walk up and down this icy surface while we tilt the lab to different angles. And based on the angle that they're able to walk up safely, we can rate based on the angle they can walk up without slipping, we can rate a given pair of footwear. So you can see this first pair of footwear is only able to walk a 1 or 2 degree incline without slipping. We'll compare that to a different type of footwear with more advanced materials in their outsoles. You can see that it's able to walk up a much steeper incline. So in this case, you can see it's going up a 10-degree incline, and in fact, he can go up a nearly a 20-degree incline with this type of footwear. And what we've learned in testing many types of footwear in this lab is that most winter footwear performs very poorly on ice. You can maybe get up a 2 or 3 degree angle before this type of footwear starts to slip. But if you compare that with some new advanced materials, advanced types of footwear, using technologies like Icelandic grip and green diamond, we see that these technologies are able to walk up angles up to 20 degrees, somewhere between 15, 17 degrees in many cases. So these incorporate, you can see the green diamond incorporates these little, you can almost see the little synthetic quartz crystals that are embedded in the outsole. The Icelandic grip incorporates what we call glass fibers in the outsoles in these patches that we've now seen stick to ice very well. You can see the results of all of our testing that we've done at this website, ratemytreads.com, and you can see the ratings that the footwear gets, the MAA score, MAA standing for maximum achievable angle. So the higher the score, the better the footwear did. We've actually found now that the footwear that does well in our lab and scores well in this winter lab also does well in real world conditions. We did a study with 110 personal support workers who wore we split them in half. Half of them wore some of the best footwear we could provide them at the time, and the other half wore their own footwear. And what we saw is the people that wore the footwear we gave them reduced the number of slips they experienced by nearly 70%, and the number of falls they experienced by nearly 80%. So a huge impact on safety with this type of footwear. However, we did notice one major limitation of this type of footwear, which was so this was an 8-week study that we did, and near the end of the 8 weeks, some of the participants in this study start with the footwear we gave them. They started reporting that they felt the footwear was losing traction compared to when it was new. So it started making us a little bit worried that this footwear that worked so well when it was brand new might wear out relatively quickly. Shreya and Hamed have since done a follow-up study to look at how this footwear performs over an entire winter season. We gave, I think, around 18 participants a pair of footwear that has this advanced composite material in the outsoles. And we had them use them as their regular winter footwear for 4 months in the winter. We had them do the MAA test at the start and then monthly for 4 months. And these were the results. And what you see is that the scores, the slip resistance scores, the MAA scores, started to drop pretty quickly with it. So this is in number of steps. We put a pedometer on everyone's shoes, so we knew how many steps they took over that 4 months. And each time they came back for an MAA test, we wrote down the number of steps that they had accumulated over that period. And what you see is the MAA score dropped, but then leveled off at what we think is a reasonable place. So around this a score of a 7 MAA score, which is actually our cutoff for reasonable performance for winter footwear. So that's a good sign that the footwear did, even though it did drop, that it did level out. However, it does highlight that this type of footwear probably is not a good choice for someone who's going to do lots and lots of walking. If you're going to be, if you're the type of person that is going to be walking 10,000 steps a day, you may not benefit from this type of footwear because it will actually wear out relatively quickly and not perform as well as you want. So So that's a good, so I think that's a reasonable sign for the types of, for example, patients that we deal with at Toronto Rehab Institute. I think people that we want to encourage to stay active and we want to make sure they're safe in the winter. I think this type of footwear is appropriate for people that are walking short distances. Um, but we still, I think, understanding how this footwear wears down, wears out is still an important thing that we need to think about carefully or measure further. One of the things we're going to do in the future, this is Davood, who's a PhD student. He is developing a device that we can put on someone's boot and let them go about their regular life, and we can. The idea is that this device will record how many times they slip uh, during their regular use. One of the things that so in the development of that, he's had 25 participants walking back and forth in Winter Lab. He's collected over 50,000 steps, 3,000 of those being slips. And one of the conclusions that he's reached is that actually ice, even with the best footwear that we have available, icy surfaces remain high risk. And you can even see that from the real world testing. Even with this good footwear, we still see lots of slips and and some falls occurring in this group of participants that we had. And so boots on their own are not going to solve this problem for us. We're also looking at training people to see if we can improve their ability to walk on ice. So this is Pedram, and he's doing his PhD, looking at how can giving people the opportunity to walk back and forth in this icy environment, to give them some practice in this icy on ice. Can we see a change in their ability to walk on these surfaces? And are there other ways of helping people walk safer? Are there directions we should be giving them? He's going to test this one. This is a public safety message from Alberta Health Services that's been around that you may have seen, that's been around for a few years, that suggests that people walk like a penguin if they're going to be around icy surfaces. And so he's going to evaluate how much of a benefit this type of instruction has. One of the hypotheses that I personally have is that telling someone, simply showing them a picture like this, or giving someone instructions without the opportunity to practice is unlikely to make a big difference in how in whether they're going to change their behavior. We can pause there for any burning questions before I go on to tripping on sidewalks. Anyone have any questions they want to type in? No, not right now. Okay. I'll keep an eye out for more questions and keep going. Tripping here. Sorry, I just have to go back. Yeah. So we'll go to our work on measuring the risk of tripping on sidewalks. Oh, I'm just going to scroll down here. Yeah. Looking at tripping on sidewalks. So we know that a lot of people trip outdoors, and we're worried about sidewalks where we have these kind of uneven surfaces where that create obstacles like this. And one of the ways we can look at someone's risk of tripping is by measuring their foot clearance during swing phase. And so what we can do, what we've developed is a way to actually measure this in real world conditions. There have been quite a few studies done in lab environments where people measure using a motion capture system with reflective markers on people, where they measure these kinds of things. But we're pretty sure that the types of measurements we get when we're in the lab are not reflective necessarily of how we walk when we're outdoors and we're more distracted. So our team has been developing a method to measure foot clearance in real world conditions, and we set up our system near obstacles like these, and we're looking to see, for example, does having this type of pavement where someone's come by with asphalt and tried to even out this obstacle? Does the risk of tripping, does the foot clearance over some of these obstacles change if you put some of this pavement? Does it change if we make it more visible with spray paint? We're looking at these kind of treatments to see if we can reduce the risk of tripping over these kinds of obstacles. Um, and the way we measure it is using a pair of cameras that are calibrated so that we can actually calculate three-dimensional coordinates of people's feet as they're walking by these obstacles on the sidewalk. So we set up these cameras on the sidewalk for a period of an hour to 2 hours at a time, and we have our team out there watching as people walk by. We record them, their feet and lower legs as they're walking by. We also scan the area, so we have a very accurate 3D representation of the surface of the ground there. We can later, Hamid has developed, on our team has developed software that allows us to combine the three-dimensional information from the cameras that we get, the three-dimensional trajectory of the foot, with the surface of the ground. And so we can actually measure the distance between the lowest part on the person's foot and the ground surface at the obstacle to see what their foot clearance values are. Any questions on that one? I'll keep going, but feel free to drop in some questions if you have any. Um, Looking at intersections, our team has been looking at intersection safety and usability, really accessibility of intersections. This is Jack. He's a PhD student on our team, working with Hamid and Niroja. And what Jack's been doing is looking to see if we can use computer vision techniques to identify features of intersections or the way we design sidewalks and these kinds of interactions to see if there are patterns that would indicate that we should rethink how we design these intersections. So for example, in this video, you saw this vehicle cut off this wheelchair user as he was trying to come across the crosswalk here. And is there something about the design of this intersection? Should there be a sign here that says stop on this line? When there's no snow, there's usually a line painted on the pavement that people are able to use as a guideline. But in the winter, when that line is gone, is that what's making it more likely that cars are cutting off pedestrians in this walkway? We can study things like that. We can also notice that this person here, I'll replay the video here, that this person, when they cross to the other side of this walkway, you can see that there's an extended area of loose snow here that's reaching up to the curb cut where the wheelchair user actually gets stuck and needs this bypass this other person that happens to be in the crosswalk to help get them free here. This is actually a recently redesigned intersection where there were these bollards, these white bollards were put in to create more space for bike lanes. But one of the effects of that is that now snowplows, it gets harder to keep this area of the crosswalk clear because of this extended area that these bollards create. So there's some interesting effects that we can study. So the goal is for Jack to see what can we do with these computer vision tools that can track people's trajectories, their walking speed, they can identify vehicles. We can start to look for interactions between vehicles and pedestrians and try to see where conflicts occurring between all of these different road users to see if there are patterns of these kind of things that might indicate safety issues or usability issues. Right now the challenge is that the city of Toronto and other municipalities kind of use serious accidents or deaths to identify the need to redesign an intersection. But these are few and far between. There's only a small number of these serious accidents that result in serious injuries. But if we can develop a computer vision system that can take an hour or two of video and start to identify patterns of some of these near misses and lower risk things that are happening, we might be able to identify risks and prevent some of these more serious accidents from happening. So that's we're looking forward to seeing what Jack's able to do with that project. Um, More things about accessibility. Our team is quite involved in a number of projects looking at how we can improve the accessibility of our environment for people with disabilities. Um, and so, like many of our patients at Toronto Rehab, um, would be people that face barriers in their day-to-day lives. For example, going to visit a national park. We know that national places like national parks and getting out in nature has many, many health benefits. But unfortunately, we also know that people with disabilities don't get to realize many of those benefits because there are so many barriers in these spaces to people to people being able to participate in the activities that are offered. Um, and and in fact, our team is has been funded by an organization called Accessibility Standards Canada. This is a new organization that came into being after 2019. The Accessible Canada Act was passed, and part of that Accessible Canada Act requires the creation of a new generation of accessibility standards. So the idea is that our research that we're doing on some of these projects will go into new standards, new national standards that will that should make these spaces more accessible. Um, the and it One of the big shifts in perspective that I think is occurring is the meaning of the word accessibility. So 20, 30 years earlier, when you say if you said the word accessibility, you would be talking about people using mobility devices, wheelchair users primarily. Nowadays, we have a much broader understanding, we have a much broader definition of what we mean uh, by the need for accessibility and the types of users that we're thinking about when we're making spaces more accessible, not only physical, but sensory impairments, as well as some cognitive communication and some other, as well as hidden disabilities. Um, and we're getting beyond what we've been arguing in some of our work with national parks, making these spaces more accessible, is we need to also get away from the idea that physically getting someone into a space is is enough to make the space accessible. We've been arguing that really what we need to do is make sure that people are able to take part in the activities that are offered in these spaces. What are we doing when we go to a park? We want to take part we want to go swimming, or we want to go camping, or we want to go on a hiking trail. We need to start thinking about how can we make sure that people with a range of disabilities can take part in all of the activities that are offered in these spaces. And so that was the framework that we really came out with and that we proposed. And the goal of our research project, this was a 4-year project that ended in March of 2024. What we did was create what we called our accessibility matrix, where the cells in this matrix provided opportunities to think about people with different types of disabilities and what barriers they faced and how we might be able to overcome each of those barriers to make more of the activities and facilities and policies that are available in a park, in a national park, to make them available to more people with disabilities. And I think I'm actually very excited about the outcome of this project. Parks Canada was a close partner on all of this work, and they've really taken some of this work and extended it on beyond our project, and they're running their own consultations with people with disabilities to figure out how they can improve a lot of their activities, facilities, and things like that. The project included doing surveys with people with disabilities, park visits. To fill in this accessibility matrix, we did reviews of the academic literature. We looked at YouTube, where people with disabilities reported on barriers to accessibility in these spaces. We ran 2 conferences actually with people. I'll give you an idea of what that looks like. where people described the barriers that they had in the first year. And then the second year, we talked more about solutions to those barriers and how we could overcome some of those barriers in parks. This is an example uh, from Lucy.
These parks contain hundreds of species, incredible views, and important cultural and natural significance. All Canadians are entitled to the ability to visit these parks, but many cannot. There are many barriers to be addressed both in and out of parks, and a major barrier is the washrooms. The lack of truly accessible washrooms in parks prevents my family and so many others from enjoying the beauty our
So
country has to
Lucy
offer.
has a sister and with some disabilities, and she highlights, I think this was a common theme in the next video, the video clip I'll show. She highlights one of the key problems with the bathrooms are the lack of information, the lack of appropriate information for her family to be able to decide whether it can accommodate her sister so that they can actually go visit a park.
Let's start with information. Before going anywhere with my little sister, we must research that place extensively. However, usually there is barely any information available. And not only is there little information, but it's hard to find. I found that usually sites mention that there is a washroom, but never specify. Is the path to the washroom paved? Is it inclined? How wide are the doors? What's the turning space? This information is needed to know if the park is actually accessible for my sister. What might be accessible for one person may not be
So what
accessible
Lucy
for
described
another.
there, that the lack of information came across as one of the our top key recommendation to Parks Canada for how they can improve accessibility is by providing more accurate, more detailed information about all of their facilities, and making sure that it was up to date. In fact, one of our park visits, this was the park map we were given, and we actually we visited this park with two people with disabilities. One of them was a walker user, and um, we made a plan. This is Georgian Bay Island National Park, and this you actually get here by ferry. So this is where the ferry drops you off and picks you up. And this is the area, the beach area where you spend your time generally, and you can do some hiking trails back here. But for most of our time at this park, we spent our time in this region, and we decided we would visit this accessible bathroom before going back to catch the ferry back to the mainland. It turned out that this washroom no longer exists. It was on their map, but it was something that was actually closed to the public a number of years ago, but the maps had not been updated. So this was the reason I think when people think about accessibility, Parks Canada initially, when they started thinking about accessibility, they always think, oh, we need millions of dollars to build new facilities and to redo the way our trails are. And it's big money kinds of structures and capital costs. But really, what we're talking about is the biggest barriers. I think what we learned from this project, some of the biggest barriers are low cost, updating your website, updating your information, making it more detailed so that people know what they can expect. Any questions on park accessibility? Feel free to jump in. I'll keep going. One of the pieces of accessibility, a subset of I guess accessibility concerns, is egressability, which is how you get people out of a building if there's an emergency. And we know that people, unfortunately, we've been making buildings, public buildings especially, easier to get into, and more buildings are accessible, people can get into them. But in the event of an emergency, they're much harder, they remain hard to get out of. So egress is not done very well. Um, and this explains why there's an 8 times higher risk of injury or death for people with disabilities compared to the rest of the population. And I think because it's in the news right now with the fire in California, it's worth mentioning that I think two of the first people who were reported to have died in the fire because of the fire were people with two wheelchair users who had called for an ambulance to help get them out. But they didn't make it. The ambulance was not able to arrive before uh, they were killed, unfortunately. So, we have legislation in this country that mandates that we need to provide equal life safety for all, but it's pretty clear we're not reaching that standard yet, and we're far from that. And so that's something that this was another project we undertook with Accessibility Standards Canada funding, and it's to highlight, to create recommendations to make egress safer. And one of the key takeaway messages that we had is this actually affects more people than we normally think of. We talk about somewhere, around 20% of the population being people with disabilities. But as Lucy's story, Lucy, her parents, and her sister is the only person in that family that I may identify as having a disability. But all four of them would be affected if her sister was not able to get out of a building in an emergency. They would all be at risk. It really affects more people than we consider normally. And there's really two approaches to egress. There's protect in place versus everybody out. Protect in place, unfortunately, is what we commonly do in Canada right now. Which is to provide safe refuge locations in our building codes. So the idea is if you're in a building and you're unable to get out, you would go to the stairwell. This is usually the fire safe location in most buildings. The safe refuge is the stairwell, and there's room for two people to wait while firefighters come to rescue you. Um, the the alternative is that you can have occupant evacuation elevators, evacuation chairs, keeping in mind, so an occupant evacuation elevator is where the user that is unable to take the stairs would be given a key to the elevator so that they could independently be able to evacuate using an elevator, a fire elevator, if there's an emergency. The evacuation chair requires someone else to lower the person down some stairs. But in fact, in 9/11, we know that there was one evacuation chair in one of the World Trade Towers, and it was an important lesson that the people that use the evacuation chair and the people that didn't listen to the rule, they were in that building. The requirement was that people were supposed to wait in safe refuge areas in the building. Of course, the buildings collapsed, and so the people that waited did not survive, while the people that broke the rules and took the elevator down did survive. And so has started a trend towards, ever since then, there is a move towards getting everyone out of the building in some form or another, and that was our recommendations for the new standards that will be coming out. And it's important to note that we often think about fire, but both fire and flooding have become more common, and there are other types of other types of emergencies that we might need to think about for evacuations, where that could include power outages, terrorism, earthquakes, hurricanes, things like that. So we created a similar matrix to the Parks project in this case, where we tried to think about people with different types of impairments and different types of buildings that they might need to be evacuated out of. What are the concerns that we need to think about with each, and what are the different solutions that are available to help make egress more effective for each of those cells? Yeah. Any questions on any of that stuff, the egress or anything that came before it? Yep. Okay. You'll see quite a few members of our team on this slide, which is our newest project that we're focused on, funded by Accessibility Standards Canada, which looks at preventing damage to wheelchairs during air travel. So it's our biggest, most ambitious project we've taken on in our team so far. It's a big problem. Many of you may have followed this in the news over the past few years, but Maya and Ziv kind of became the face of this problem in 2022, in September 2022, when she flew, I think it was flying to Israel, and she arrived there to find that her wheelchair had been damaged beyond use. It was, and she it highlighted this challenge that's been an ongoing problem. This is actually her wheelchair that before the flight, she actually had packaged it up to try to prevent any damage from occurring. And this is the condition that she got it back in. And so our team was asked by the Canadian Transportation Agency, as well as Accessibility Standards Canada, to try to figure out where in this, like, what are all of the reasons that this damage might be occurring, and to make recommendations to try to prevent this damage from occurring. One of the most exciting parts of this project that we're going to do is put these little, Davude on our team has developed a little inertial sensor, data logger that we're going to put on different people's wheelchairs and ask them when they're flying, and so that we can see what's happening to these devices. We suspect that the damage is mostly occurring during loading and unloading. And in particular, it's when they're being loaded onto narrow body aircraft. A narrow body aircraft is where they're often called single aisle aircraft. So you have a single aisle going down the middle and seats on both sides. The cargo spaces in those aircraft are smaller, and the door to the cargo areas tend to be smaller, which means that the wheelchairs are, when they're being loaded, they're unable to go in upright. They often have to be tilted on their back or on their sides. We think that's when the damage is occurring. But we're going to try to learn more about this to try to understand what's happening. One of the members of our team, who's a wheelchair user, flew to the UK recently and took this sensor, put the sensor on her wheelchair. And what we see in this initial data is there is far more going on during the loading and unloading process compared to what's happening during the actual flight itself. You can see here's takeoff and landing. There's a little bit of acceleration being recorded. But you can see far more action happening here. And so we're going to try to understand better what's happening during the loading and unloading process. We're also working with, I think one of the things that the CTA is worried about is that this damage could be occurring during the flight itself. And currently there are no standards for how these devices should be strapped down when they're in the cargo spaces. And so we're coming up with, part of this project includes taking some different mobility devices, a range of mobility devices, putting them in our simulator. This is our motion simulator at Kite in the basement, where we're going to replay some of this data from the flight, the takeoff, some turbulence and landing, while strapping in these wheelchairs, simulating luggage being piled around them, to see if see where some of this damage could be occurring and how it could be occurring, and if there's any issues with how the devices are strapped down. One of the recommendations we already have is to use these Q-straint type tie downs, which is not what they use currently. What they currently use is the same type of ratcheting tie down straps that you might use to tie a canoe to the roof of your vehicle, where you can tighten them by ratcheting them. And the problem with those are that they can be over tightened in some cases. So especially for lightweight wheelchairs and carbon fiber, aluminum, lightweight manual wheelchairs, there are a lot of reports of them getting bent or cracked, the frames being bent or cracked, we suspect because these straps can get over tight. And so we're going to try to understand more about where this damage is occurring, but we have some hypotheses that we're going to start testing. Any questions about air travel or anything on that topic? Okay. I'll just briefly introduce the last project that I wanted to quickly introduce to you here, which looks at preventing caregiver back pain. So this is, we have Dawood who developed the latest version, who's going to explain in a video here how this system works and what the problem is. But Faranak and Shreya are helping on this project as well.
Low back pain is a huge problem for healthcare workers. A paper published in 2020 found that over 70% of workers experienced low back pain and half experience severe pain daily. So we've developed a tool called Posture Coach to help address this problem by helping to shift these workers to using safer patterns of movement. It does this by providing a gentle vibration or audible beep when the user flexes their lumbar spine too far.
All right, Hamid, so we're gonna first take off just gonna adjust here. I want you to lift your leg up for me here.
Our studies have shown that people without any caregiving experience wearing this system for about an hour a day for 2 days is enough to significantly reduce the amount of lumbar spine flexion they use. And this shift in behavior is retained even 2 months later.
So that gives you an overview of what the project does. In this case, Dawood is describing it for paid healthcare workers. We know the problem is bigger than that. It's not only, that's one population that we could be focused on. Another is family caregiver population. So paid and unpaid caregivers. We want to find ways to help train them, help them learn how to use safer patterns of movement, as Dawood said. And really the key pattern that we're trying to teach, the pattern of movement that we want people to adopt is what we call hip hinging. So getting people to bend from the hips when they have to bend over rather than flexing their spine. And this is the core, whenever people talk about body mechanics and lifting and moving people, at the core of that is trying to get people to do this activity. There's some controversy over how valuable this particular approach is, but from a perspective of trying to think of all the ways we can help people, I'm pretty convinced that helping people learn how to do this is a good idea. And so we think that just telling people how to do it, which is how, unfortunately, most training these days, most healthcare workers, it's like an emperor has no clothes kind of situation where we sit people down in a room and we show them these pictures and we give them this feedback. They might even practice doing a little bit of these movements in this kind of environment. But we're pretty sure that we shouldn't be expecting to see injury or pain reduction from just passing on this knowledge. If you want to get we need to find a way to actually change people's behavior, change how people move when they do this thing. It's like any sport. If you're trying to work on your golf swing or something, imagine trying to learn to do a better golf swing by watching, by looking at PowerPoint slides and sitting in a classroom. You obviously need to practice while someone is watching you and giving you feedback from time to time. So the idea is that our posture coach device could be that coach that gives you feedback. The goal is to see if we can get posture coach to shift people's behavior. We think that as Dawood said in the video, in our lab-based studies, we think it's worked well, and even just wearing it for 2 days leads to changes in behavior that lasts up to 2 months. We're about to start testing with personal support workers to see what happens when we have people in real world environments. It's very, there's a good chance that people may be more distracted in these environments, not as able to focus on their movements, so it may not be as effective in that environment, but we're going to find out. So that brings me to the end of my presentation. I'm happy. I think there's still maybe 8 or 10 minutes left, so I'll turn it back to Alina. If there's any questions, I'm happy to take those. My email is on the slide there, so if you have any questions, you can certainly always feel free to email me as well.
Yeah, thank you very much, Tilak. That was a fantastic presentation, packed with lots of important information about safety and accessibility. I found it really interesting, and I like that you gave specific action items that we can all do to help improve safety and accessibility in our communities. So if anybody has any questions, whether that's online or in person, you can feel free to ask them now. I believe if you're in person, Cesar can help you ask a question. And I believe there is a question in the chat. Oh, sorry, not a question, just a comment.
Yeah, would you like to, do you want me to read it out?
I can read it. It
Sure.
says, thank you, Tilak and team, for sharing an overview of these important topics on safety and accessibility for individuals with disabilities and caregivers. Such valuable and relevant work. It's reassuring to know that your team is being engaged and that the work is translating to community planning and safety of its members. And I couldn't agree more.
Thank you very much, Joanne. And I know, Joanne, we've been working together for a number of years on the Falls Committee at Toronto Rehab, and yeah, getting more. I think there's obvious. I think there's a lot of ways we should be working together more, and finding ways to take some of this research and make sure that the patients that we deal with here are benefiting from it. Is Rate My Treads current? Yeah, I think, yeah, it is current, Cesar. I see your question there. Yeah, it is up to date. It gets updated every time we get new boots. They get there's a team. I'm not involved with Rate My Treads directly. There's actually this is one of our spin-off companies actually at from Kite that and the data that they're testing new boots all the time, and the data gets updated as they test.
Okay.
Yeah, I'll
Okay.
say one more word about that. I think the most exciting part of Rate My Treads, people talk about the delay in getting research findings into meaningful, outcomes for real people. I think this is like the best example I've ever seen of an idea, the number of years it took to take the concept and to realize it has is incredible, really. And we actually believe that by having this website where footwear gets rated and the ratings are public, the footwear manufacturers started telling us right away that they were selling out of the footwear that performed the best. And all of a sudden, there was this incentive, very strong incentive for the footwear manufacturers to make better footwear that would get rated better. We're pretty confident that we've shifted the safety of the whole footwear industry as a result of having this website. It's pretty incredible. The one thing that right now, as I mentioned, is that we're concerned about is that the manufacturers could be gaming this system by creating footwear that gets rated really well when it's brand new, but then wears out really quickly. And so now what I'm arguing we need is to add a column in there for after 100,000 steps, what is the rating then, right? So you have new and 100,000 steps later, what's your rating? We've actually just gotten funding for a robot, an industrial robot arm that we want to use to be able to do this kind of repetitive step wear thing in an automated way, so that every pair of footwear that gets tested gets this kind of wear rating as well. I see Kristen. Thank you for your comment. And Cesar is asking, why do women's boot rate lower than men's? I don't know. I didn't notice that. Is that a pattern you're seeing there? There are definite, Cesar, there's definitely more to understand about this, about the interaction between surface area. Women will generally have smaller boots, will weigh less. These various interactions. I'm not sure if anyone has really dug into these various effects yet, but it's something definitely that we should be looking at closer. Yeah.
Looks like there's one more question from the in-person participant.
Oh, yeah. This is amazing regarding Rate My Treads. can you speak about the strategy to get this information to the community? And is there information you can share with us that we can share with our patients? The strategy that is being applied now to get this word about Rate My Treads out there is to try to get as much publicity about it as possible. So CBC has done a number of stories over the years on on our testing and the fact that this website is out there. But I guess there's just less people that watch TV these days, watch CBC. I know maybe you're right. Maybe there needs to be better ways, more we should think about, I don't know, YouTube ads or something, right, to get this message out more. That's an interesting thought. Is there information you can share with us that we can share with our patients? Yeah, I mean, the information you can share with your parents, I mean, with your patients, I should say, is just to I think the practical stuff really that comes out of this presentation right now is the Rate My Treads website to provide that website. I guess maybe some patients may not be able to access a website or make use of that information directly. That's an interesting thought, that whether we should have a pamphlet perhaps with the information there. Maybe that's something we could think about. I know, Alina, feel free to jump in, and I know we're down to the last minute here. I see another, you want me to do this
Yes,
one more?
well, that's up to you. If you have a couple minutes to
Yeah,
stay online, then that's up to you for sure.
yeah,
But maybe
great.
I'll just say goodbye to everybody else in the meantime. So thank you, every Kite website. And thank you. But yes, why don't you answer that question as well? Thank
Good.
you.
Thanks, everybody. Thanks for joining us. Um, yeah, the posture coach. Yes, have we thought about piloting in schools? Yeah, I think like PSW. I was actually talking with Conestoga College. They have I can't remember what it's called, but the Canadian Workplace Injury Prevention something school, like a research group there that's associated with Conestoga College, where they also train PSWs. They have PSW training programs there. And you're absolutely right, Cesar, that is I think one of the most effective places we could be doing this. My personal, my gut says that people, once they have been doing this job for a while, if they're a professional healthcare worker, it's going to be hard to shift their behavior, or harder to shift their behavior than someone who's new at this kind of stuff. So you're right that I think the best target for this could be the could be in school. Yeah. Thank you, Zia. Canadian Institute for Safety, Wellness and Performance is the name of that organization. Thank you. Yeah.
Okay. Well, if there's no other questions, thank you so much for your talk today. I found it really interesting, and we'll see everybody next time.